Hello everyone. We are going to discuss the S block elements today. While making this video, I have tried my best to talk about all the topics that have been covered in NCERT books and also explore more topics in further details wherever required. Today we will discuss the chapter 10 of class 11 NCERT book, the S block elements. S block comprises of 14 elements, that is 7 elements from group 1, 6 elements from group 2 and 1 element from the group 18 of the periodic table. Except hydrogen and helium, all elements are metals. They are shiny, silvery and good conductors of heat and electricity. Group 1 metals are also called alkali metals because they react with water to form hydroxides which are strongly alkaline or basic in nature. Whereas group 2 metals are called alkali earth metals or alkaline earth metals because they are mostly found in Earth's crust. Their oxides or hydroxides are also alkaline in nature. Beryllium is an exception to this as it is not alkaline but amphoteric in nature. The last element of group 1 and 2, that is francium and radium, they are highly radioactive metals. Let us discuss some more properties of this radioactive element. Francium has 34 known isotopes with atomic masses ranging from 199 to 232. Whereas radium has 33 known isotopes with atomic masses ranging from 202 to 234. Only two isotopes of francium are naturally occurring. They are francium 221 with a half-life of 4.8 minutes and francium 223 with a half-life of 21.8 minutes. In case of radium, only 4 isotopes are naturally occurring. They are radium 223 with a half-life of 11.4 days, radium 224 with a half-life of 3.64 days, radium 226 with a half-life of 1600 long years, and radium 228 with a half-life of 5.75 years. Among all these, radium 226 is the most stable isotope of radium as it has the longest half-life. Francium is the rarest naturally occurring element on Earth, as at any given time, the total mass of francium in the Earth's crust is not more than 30 grams. Whereas radium is the rarest of all alkaline earth metals, comprising only 10 to the power minus 11% of Earth's crust. Or if we talk about the percentage composition of only igneous rocks, it is 10 to the power minus 10%. Of all the elements in a group, the first element behaves differently to other elements of their group. And it is because of something which is explained as diagonal relationship. The behavior of the first element of a group is similar to the second element of the next group. That is, lithium is more similar to magnesium, like lithium and magnesium both form hydrates while none of the metals below lithium in the first group form hydrates. Beryllium is more similar to aluminum because beryllium and magnesium both are amphoteric in nature. They react with acids as well as bases. Boron is more similar to silicon as both are semiconductors. If we talk about the electronegativity of elements in the second and third period, we see that electronegativity is more similar for most diagonal elements as compared to the adjacent left, right or top down elements. This diagonal relationship is seen to arise because of similarities in the ionic sizes and the charge by radius ratio of these ions. One of the major uses of salts of S block elements is in the manufacturing of firecrackers. We love to burst firecrackers and S block metals are highly famous for being used in them. Their salts impart characteristic color to an oxidizing flame. For example, when you burn sodium salt, it gives you yellowish flame. Potassium gives purple colored flame, strontium gives red colored flame, and barium gives green colored flame. All this happens because the outermost orbital electrons are excited to a higher energy level. When the excited electrons come back to the ground state, radiation is emitted in the visible region of the spectrum. So next time when you burst Diwali crackers, keep in mind that you are playing with S block elements. Ions of S block elements play a vital role in sustaining life. Ions such as sodium, potassium, calcium, and magnesium are found in large proportions in biological fluids. It is so because they help to maintain ionic balance in our bodies or in any other living beings. They are also responsible for conduction of nerve impulses, that is, transmission of electrical signals or messages between our organs and the nervous system. So next time when you feel thirsty, remember that this message has been conveyed to your brain with the help of S block elements. Or when your body shows a reflex against a hot object or an electrical shock, it has all been possible because of S block elements. So you see, S block elements are all around us, not just outside but also inside us. Be it our concrete homes, parks, water bodies, land, or in the sky. S block elements are everywhere. That is why it is important that we know about them, explore their nature and properties, so that we can use them more efficiently and scientifically. In this lecture, we have discussed the introduction part of S block elements from the NCERT book. We will start with the physical properties of S block elements in our next lecture. Thank you for watching.